Welcome to AWS IAM Permission Boundaries. Welcome everyone. Today, we're diving deep into one of AWS's most powerful security features, IAM Permission Boundaries. Think of permission boundaries as a safety net. They ensure users and roles can never exceed certain permissions, no matter what policies are attached to them. This presentation will take you from the basics to advanced implementation. We'll include real AWS CLI commands and practical examples you can use in your environment. We'll cover why you need them, how they work, and most importantly, how to implement them step by step. By the end of this session, you'll understand how to create a robust security framework that gives developers freedom while maintaining strict security controls. Let me explain permission boundaries using a simple analogy. Imagine you're a parent giving your teenager a credit card. You might attach policies that say you can spend money on food, gas, and school supplies. But as a safety measure, you also set a spending limit of $500. Permission boundaries work exactly like that spending limit. No matter what permissions or policies are attached to a user or role, they can never exceed what is permitted by their permission boundary. It's AWS's way of saying you can have these permissions, but never more than this ceiling. This is crucial for organizations because it allows you to delegate permission management while ensuring security guardrails are never violated. How permission boundaries work architecturally. Let's look at this diagram to understand the flow. When a user or role tries to perform an action in AWS, the system performs the effective permissions calculation. First, it takes all the identity-based policies attached to the user or role, which grant permissions. Then it applies the permission boundary as a filter. The result is an intersection, meaning you only get permissions that exist in both your policies and your boundary. Think of it like two circles overlapping in a Venn diagram. The overlapping area is what you can actually do. If something isn't in your boundary, you can't do it, period. This gives security teams ultimate control while allowing operational flexibility. While every organization needs permission boundaries solve real-world problems that every growing organization faces. The biggest challenge is what we call the delegation dilemma. How do you give teams the ability to manage their own permissions without risking security breaches? Without boundaries, if you give someone IAM permissions to manage their team, they could potentially give themselves admin access. It's like giving someone the keys to the building and trusting they won't enter restricted areas. With boundaries, you can confidently delegate IAM management because the boundary acts as an unbreakable ceiling. Teams can create and modify policies within their sandbox, but they can never exceed the security perimeter you've defined. This enables true DevOps autonomy while maintaining enterprise security standards. Now let's get hands-on and create our first permission boundary. We'll start with a practical example. Creating a boundary for developers that allows them to work with common services but prevents them from doing anything destructive. The AWS CLI command we're using here creates a managed policy that will serve as our boundary. The policy document parameter accepts a JSON policy that defines the maximum permissions. Notice we're including S.3, EC2, Lambda, and CloudWatch access, but excluding IAM and billing access. The description is important for documentation. Always make it clear what this boundary is for. The path parameter helps organize your policies, especially in large organizations. After running this command, AWS will return an ARN, that's Amazon Resource Name, that uniquely identifies your new boundary policy. Let's break down the developer boundary policy document line by line. Understanding its structure is crucial for creating effective boundaries. The effect field, set to allow, means we are granting permissions. Remember, boundaries define the ceiling asterisk, not the floor. The action array in each statement lists the specific API calls that are permitted within this boundary. For S.3, we are allowing bucket listing and object operations, but note that we are not allowing bucket deletion or policy changes. For EC2, we allow instance management and key pair operations, but not VPC modifications or security group changes that could affect network security. The Lambda permissions allow function creation and management, which is essential for serverless development. CloudWatch Access enables monitoring and debugging, which developers need for troubleshooting. What is not included is equally important. No IAM changes, no billing access, no VPC modifications, and no account-level operations. Applying permission boundaries to users. Creating the boundary is only half the battle. Now we need to apply it to users. This is where the rubber meets the road. The put user permissions boundary command is how we attach our boundary to a specific user. The username parameter specifies which user gets the boundary, and permissions boundary takes the ARN of the boundary policy we just created. This is a critical security operation. So AWS requires explicit attachment. Once attached, this user can never exceed the permissions defined in the boundary, regardless of what other policies are attached to them. It's like putting a speed limiter on a car. The car might be capable of going 120 miles per hour, but the limiter ensures it never exceeds 65 miles per hour. You can verify the attachment using the getUser command, which will show the boundary ARN in the response. Creating boundaries for service roles. Now let's create a more sophisticated boundary for service roles. In enterprise environments, you often have automated systems and services that need specific permissions, ensuring they cannot be misused. This enterprise boundary is more restrictive and focused on production services. Notice how we're being very specific about the actions allowed. For EC2, we're only allowing read operations and specific instance actions, not creation or termination. The S.3 permissions are limited to specific bucket patterns using wildcards. This is a powerful feature. You can restrict access to buckets that follow naming conventions like company prod or department data. CloudWatch permissions focus on logging and monitoring, which are essential for production services but don't pose security risks. This boundary would be perfect for application roles that need to run in production but shouldn't have broad access. Creating roles with built-in boundaries. Here is something really powerful. You can attach permission boundaries when creating roles, ensuring they are protected from the moment of creation. The create role command with the permissions boundary parameter does exactly this. The assume role policy document defines who can assume this role. In this example, we are allowing EC2 instances to assume it, which is common for application roles. The trust policy is separate from the boundary. The boundary controls what the role can do, while the trust policy controls who can assume the role. The path parameter is useful for organization. You might use paths like application roles or developer roles to categorize your roles. This helps with both organization and automation scripts. Notice that we are setting the boundary at creation time. This is a best practice because it ensures the role is never without a boundary from the moment of its creation. Attaching policies within boundaries. Now comes the interesting part, attaching actual policies to our boundary-protected role. Remember, the boundary defines what's possible, but the role still needs policies that grant specific permissions within that boundary. The attach role policy command attaches a managed policy to our role. You could also use the put role policy command to attach inline policies. The key thing to understand is that the effective permissions are the intersection of the attached policies and the boundary. For example, if your boundary allows S.3 getObject, but the attached policy allows S.3 deleteObject, the role can only perform getObject operations. The boundary acts as a filter that removes anything not explicitly allowed. This is why it's important to make your boundaries comprehensive enough to support the legitimate work the role needs to do, but restrictive enough to prevent abuse. Managing and monitoring permission boundaries. Once your boundaries are deployed, you need to monitor and manage them effectively. Let's look at the essential commands for day-to-day boundary management. The list entities for policy command is incredibly useful because it shows you exactly which users, roles, and groups are using a specific boundary. This is crucial for impact analysis before making changes. The getUser command shows you all the details about a user, including their attached boundary. This is your go-to command for troubleshooting permission issues. The simulate principal policy command is like a what-if analyzer. You can test whether a user or role would be able to perform specific actions without actually attempting them. This is invaluable for testing boundary effectiveness. Use these commands regularly to ensure your boundaries are working as expected and to troubleshoot any permission issues that arise. Let me share some real-world boundary patterns that work well in different organizational contexts. These aren't just theoretical. These are proven approaches used by companies ranging from startups to Fortune 500 enterprises. The developer sandbox pattern gives developers broad access to development services while preventing them from affecting production or security-critical resources. This enables fast iteration while maintaining guardrails. The production service pattern is for automated systems and applications running in production. These boundaries are more restrictive and focus on specific operational needs rather than broad access. The department isolation pattern uses boundaries to prevent cross-contamination between different business units. Marketing can't accidentally access engineering resources, and vice versa. The contractor temporary access pattern provides time-bound or scope-bound access for external parties or temporary team members. You can give them significant permissions within their boundary while ensuring they can't access other areas. Let's talk about the most common issues you'll encounter with permission boundaries and how to resolve them. These scenarios come up frequently in real deployments. The access denied despite policy issue is the most common. When someone has a policy that should allow an action, but they're getting denied, the boundary is usually the culprit. Use the simulate principal policy command to test the effective permissions. Boundary version conflicts occur when you update a boundary policy, but some entities are still using an older version. Remember that AWS keeps multiple versions of managed policies. Service-linked role issues happen when AWS services try to create roles that conflict with your boundaries. You need to plan for AWS's automatic role creation. Cross-service permissions problems occur when one AWS service needs to call another on behalf of your role, but the boundary doesn't allow it. This is tricky because the error might not be obvious. Understanding boundaries versus traditional policies. This comparison highlights the fundamental differences between permission boundaries and traditional IAM policies. Understanding these differences is crucial for designing effective security architectures. Traditional policies are additive. Each policy grants additional permissions. Boundaries are restrictive. They set absolute limits. Think of policies as saying you can do this, and boundaries as saying you can never do more than this. The scope difference is also important. Policies can be attached to users, roles, and groups, but boundaries apply only to users and roles, not groups. This makes boundaries more precise but requires individual attachment. The evaluation order matters. AWS evaluates explicit denies first, then checks boundaries, then evaluates allow policies. If any step fails, the action is denied. Use boundaries for governance and guardrails. Use policies for granting specific operational permissions. Production-ready best practices. These best practices come from years of real-world implementations and lessons learned from both successes and failures. Following these guidelines will save you from common pitfalls. Version control your boundary policies just like application code. Use tools like CloudFormation or Terraform to manage them. This ensures repeatability and provides an audit trail of changes. Test boundaries thoroughly before deployment. Create test users and roles. Attach your boundaries and verify they work as expected. Use the policy simulator extensively. Monitor boundary effectiveness with CloudTrail. Look for patterns of denied actions that might indicate boundaries that are too restrictive or legitimate use cases you hadn't considered. Plan for exceptions and emergency access. Sometimes you need to temporarily exceed boundary limitations for critical incidents. Have a documented process for this. Regular boundary audits should be part of your security review cycle. As your organization evolves, your boundaries should evolve too. As your organization scales, manual boundary management becomes impractical. Let's look at automation strategies that make boundary management scalable and consistent. This script template shows how to automate boundary assignment based on user attributes. You might trigger this when new users are created or when users change departments. The key is integrating with your identity management system. The script checks if a boundary already exists before creating it, preventing duplicates. It also includes error handling for common scenarios like network issues or insufficient permissions. Consider integrating this with your CI/CD pipeline so that boundary changes go through the same review and testing process as code changes. This brings the same quality controls to security policies that you apply to application code. You can extend this pattern to automatically rotate boundaries, audit compliance, and even automatically adjust boundaries based on usage patterns. Using boundaries for compliance. Permission boundaries are incredibly powerful for meeting compliance requirements. Let's explore how they help with common regulatory frameworks and audit requirements. For SOC 2 compliance, boundaries help demonstrate that you have technical controls to prevent unauthorized access. Auditors love seeing that employees can't exceed their defined access levels, regardless of what policies are attached. PCI DSS requires strict access controls around cardholder data environments. Boundaries can ensure that even administrators can't access payment-related resources without explicit audited policy attachments. GDPR compliance benefits from boundaries that prevent accidental access to personal data. You can create boundaries that explicitly exclude personal data stores, ensuring privacy by design. The key for compliance is documentation and auditability. Every boundary should have a clear business justification, regular review cycles, and detailed logging of who can assign or modify them. Boundaries for cost control. Here's something many organizations miss. Permission boundaries are excellent for cost control. By limiting what resources users can create or modify, you can prevent costly accidents and runaway spending. This cost control boundary prevents users from launching expensive instance types or creating resources in costly regions. The instance type restrictions ensure users can't accidentally launch GPU instances when they meant to launch basic compute instances. The region restrictions keep resources in your preferred regions, which might have better pricing or comply with data residency requirements. Many organizations have been surprised by bills from resources created in expensive regions. You can combine this with resource tagging requirements to ensure all resources created within the boundary follow your cost allocation and tracking standards. Consider creating different boundaries for different environments. Development boundaries might be more restrictive than production boundaries to control costs in non-critical environments. Monitoring and alerting for boundaries. Effective boundary implementation requires continuous monitoring. You need to know when boundaries are preventing actions, whether those preventions are legitimate, and whether your boundaries require adjustment. CloudTrail is your primary tool for boundary monitoring. Look for events with error codes like unauthorized operation or access denied. These might indicate boundary-related denials. Set up CloudWatch alarms for unusual patterns of denied actions. If a user experiences a sudden increase in denied requests, it might indicate they need additional permissions within their boundary, or it could signal a security incident. The key metrics to monitor include denial rates by user and role, most commonly denied actions, and changes to boundary policies themselves. These metrics help you optimize your boundaries and detect potential issues. Consider creating dashboards that show boundary effectiveness and compliance. Security teams need visibility into how boundaries are protecting the organization. Your implementation roadmap. Congratulations, you now have a comprehensive understanding of AWS IAM Permission Boundaries. Let's talk about how to implement this knowledge in your organization. Start small with a pilot group, perhaps the development team or a specific project. Create boundaries for this group, test thoroughly, and iterate based on feedback. This gives you experience without affecting the entire organization. Plan your boundary hierarchy before you start. Think about the different types of access your organization needs and design boundaries that can scale. Consider boundaries for developers, operators, read-only users, and service roles. Integrate boundary management into your onboarding and offboarding processes. Every new user should get an appropriate boundary, and departing users should have their boundaries reviewed. Most importantly, treat boundaries as living policies. Review them regularly. Update them as your organization evolves, and always be ready to adapt based on new requirements or lessons learned. Remember, permission boundaries are about enabling secure innovation, not restricting it. When implemented well, they give teams confidence to move fast while maintaining security standards.